Hey, Math 1030. This is lesson 9A. We're going to be talking about functions today. Mathematical models are based on relationships between quantities that can change, such as a relationship between wind speed and stress on a bridge. More wind equals more stress or leads to more stress. Or the relationship between worker productivity and unemployment. Any kind of relationship, well, maybe not any kind. A lot of mathematical relationships are functions or qualify to be called functions. So that's what we're focusing on today. A function just describes how a dependent variable changes with respect to one or more independent variables. When there's only two variables, like an x and a y, they're often summarized as an order pair, like a point, with the independent variable first. So our independent variable would be the x value, and the dependent variable would be the y value. Um, the dependent variable is a function of the independent variable, or in other words, the y value depends on the x value. So that's why the y one is called dependent, because y depends on x. Um, Another way to think about it is that the independent variable is going to have some kind of effect on the dependent variable. So a lot of the homework on this lesson is giving you different scenarios, and you have to kind of decide which one's independent and dependent, or whether it can be described as a function or not. And so some of it is, I don't know, maybe not super straightforward. You do have to do a little bit of MyMathLab channeling to guess what they want, because they honestly aren't 100% consistent. So we're going to go through a couple of examples here for deciding if it could be described by a function, and then we'll do a couple of examples of choosing statements or making statements to describe, and then we're going to look at a couple of graphs. And then that will be it. So for this first example, we want to state whether the two variables are related in a way that might be described as a function, and if so, identify the independent and dependent variables. So a lot of this depends on if you have some background knowledge on the topic or not. This one is about riding in a hot air balloon. As the balloon rises, the surrounding atmospheric pressure decreases, and that's what causes your ears to pop. So first of all, this one can be described as a function. In this case, most of the time when it says a statement like with the word as, most of the time it's the most of the time it is the x coming first and then the y. There's one or two exceptions to that, but most of the time they're just not 100% consistent with MyMathLab. So, as you go higher and higher, the atmospheric pressure goes down. So our independent variable is going to be our altitude or our height. And the dependent variable is going to be the atmospheric pressure. In other words, the pressure, the atmospheric pressure depends on your height. So it's usually like y depends on x. Okay, so let's look at another one. You're on a barge headed south down the Mississippi River. You notice that the width of the river depends on how far you have traveled down the river. So the width of the river, that's going to be our y value, and it depends on how far you've traveled. That's going to be our x value, our independent variable. So this one can be modeled as a function. The independent variable is the x value. That's distance traveled down the river. And then the y value, the dependent variable, is going to be the width at the river. So at every particular moment after you've traveled down the river will have a certain width at that distance. Okay, the next one, you walk through a used car lot and list the price and model year of each car you see. This one is our no example. This can't be modeled as a function. You might have a 1986 car that's worth tons of money because it's a classic, valuable car, and you might have a really beat up one. So this one's going to be a little money. This one might be lots of money because it's awesome. So knowing the year doesn't really give you information about the value, but also if you knew a car cost a little bit of money, it might be like a really beat up car from 2013, or it might be a car from 2006 that's in good shape but is very old and has a lot of miles. Or you might have a super expensive car that is a classic, 1964, fancy car, classic, or it might be, a newer car. So knowing the value of a car doesn't really tell you a lot about its age, and knowing its age doesn't really tell you a lot about its value. So we don't list an independent or dependent variable here because it is not a function. Okay, the next type of question you'll have has to do with like deciding on a statement to describe how the relationship between the two variables works. So it will give you an ordered pair, and then you have to choose from a list of 4 statements, and it's multiple choice. Now, the tricky thing here is on number 4 and number 6, the correct statement lists the x value first. But on number 5, the correct statement lists the y value first. So on number 4 and 6, choose one that starts with your x variable. On number 5, choose one of the statements that starts with your y variable. It makes me crazy that they are not consistent, and there is literally no rhyme or reason to which one that they went with. So anyway, so on this first one, as your or as a person's blood alcohol content increases, so as they get more drunk, their reflex time would decrease. So definitely, so this will be all about increasing and decreasing, and you'll just look for the correct statement. But as you have more blood alcohol content, your reflexes go down. As a child's age increases, their shoe size increases. I mean, at least until they're fully grown. And then this last one switches on us, so it puts the y value or the y variable first as the cost of driving decreases. So it's less money to drive. What's the relationship between that and your gas mileage? Well, if it's costing you less money to drive those 500 miles, your gas mileage must be increasing, or it must be higher. That one is kind of strange, but it is what it is. All right. The final type of homework is going to have to do with looking at tables and graphs. So for every function, there are 3 basic ways to represent it. Via a table of values, by showing you a graph or a picture of the data, or by giving you an equation. So next lesson is going to focus on equations, but you'll have a few homework problems in this assignment from 9A that will have to do with tables and graphs. Now, sometimes it will show you the table and the graph and ask you some questions about it. Sometimes it will give you a table of values to start, and one of your jobs is to pick the correct graph and then answer some questions about it. So there's like maybe 3 or 4 of these questions. So here's one. We have this data table showing altitude and air pressure. And so we need to identify the independent and dependent variables, and we need to describe the domain and range. On your homework, you'll also be matching the graph, but on this one, I'm just showing you the correct graph. When you are matching correct graph, I would make sure your independent variable is on the x-axis and that your dependent variable is on the y-axis. That's one way to eliminate some of the incorrect graphs. But then beyond that, you'll just be looking for, those points to correspond. So again, the x value or the x variable is our independent variable, and our y is our dependent. So the independent variable here is altitude. And then the dependent variable is the pressure. So domain has to do with x values. So the domain for this function, and if you have the table of values, I would use the table of values. It's a little bit easier to grab tables of values or numbers from the table of value than it is for the graph, especially the microscopic MyMathLab graphs. So I would definitely use the table of values here. The domain of the function, we're just looking for, those values that the x variable could take on, and it looks like our domain would be from a low value of 0, and these are altitude, sorry, in feet, from a minimum of 0 feet to a maximum value of 30,000 feet. And then the range of the function, and range is y values. So for the range of the function, we'll be focusing on our y values right here. It's definitely going to want you to list them from the lowest to the highest. So it looks like our lowest value is between 10 up to 30 inches of mercury. So if you're working on those graphs, it may also ask you to describe the shape of the graph. So if I was describing this one, I would say that it is decreasing, but the rate of decrease is getting lower at higher altitudes. So it's decreasing, but the higher you get, it's just not decreasing as much. So that rate of decrease, it's a slower rate at higher altitudes. Watch your MyMathLab rounding statements. Sometimes it'll have you round to the nearest whole number. So just watch those rounding statements and pay attention to what it's asking you. If you round it to the nearest, tenth or something, and it asks you for the nearest whole number, that's not going to be right. It may even ask you to round to the nearest 10, maybe to the nearest 5. It may just depend on the graph. So just watch out for that and make sure you're reading carefully. And I think that's about it. So good luck on this homework. Let me know if you have any questions. I'm more than happy to help. And I guess that's it. Thanks.